All right, hi everyone. Today we're going to be talking about vector. Okay, it's a new chapter in NMATS Form 5. It's chapter 4. Okay, and I know that the other two classes, S1 and S3, you guys may be doing other chapters right now, but it's okay. I decided to stick to the plan, which is to teach vector anyway, because I feel that I feel that I should just stick to the plan or whatever the plan was originally lah. Okay, so if you have your modules with you, it will be good to open it. But if not, I also want to recommend. I also want to recommend that you have your textbooks with you lah. Okay, because not because I will give exercises from textbooks, but because at this point in time, some of you don't have the means. Ada yang memang tidak dapat print keluar. Okay, ada yang memang tidak dapat print keluar, ada module. So it's good to do exercises from the textbook. Okay, especially if you can't print it out lah. Okay, so the module is just for us to berbincang during this lesson. Okay, but ideally, if you can do exercises from the textbook. Okay, and towards the end of the class, I may give a small briefing about the kerja project matematik tambahan. And I will need to refer to the textbook for that. Okay, so let's start. So for those of you who are in science class, the word vector is not something new. Okay, you will have heard of this word vector before. We know that all physics quantities are divided into two. One is called scalar quantities, and the second one is called vector quantities. Okay, and the difference between the scalar quantity and the vector quantity, or okay, for those of you who don't know what is the word quantity, numbers lah. Okay, scalar numbers or vector numbers. Okay, scalar numbers are numbers that has the value only. Dia ada nilai sahaja. Okay, but vector numbers, vector quantities are numbers that not just have value, but they also have a certain direction in which they are going. Okay, so for example, okay, I'm going to start showing this to you now. So, okay, this is how we show okay, a certain vector quantity. Okay, let's say you have a ship over here. Okay, you have a ship in point A over here. Ship as in kapal. Okay, not tai. Okay, and then this ship is going from point A all the way to point B. Okay, so that means that this ship is going from A to B in a certain direction. Of course, kita boleh kira this jarak lah. Okay, this jarak is the number, and this direction is shown by the arrow. Okay, so we're not just interested in how far the ship is going, but we also want to know which direction he's going. And that is called a vector. Okay, so a vector is a line or is a distance between 2 points that has a certain direction. Okay, and the direction is very important. You go to the right and you go to the left, is two different directions, you know. Okay, for example, if you let's say if you are standing let's say you're standing in the middle of block, what's the block called? You're standing in between the guys and the girls' toilet lah. Okay, the two classes in the middle. If you go to the left and you're facing the class if you go to the left, you're going to the girls' toilet. If you go to the right, you're going to the guys' toilet. Okay, so as a person, let's say as a student, if I'm a male student, of course I want to turn to the right. My direction is very important. The distance is the same. Okay, maybe it's about 5 meters lah. The distance is the same, but the direction is very important, no? Because if I go to the right, then I'm going to the right toilet. If I go to the left, walaupun dia jarak yang sama, okay, then it's like, oh no, something is wrong with me. Okay, I'm not supposed to go to the girls' toilet, but I'm going there instead. Okay, so vector is all about a certain distance, okay, or a certain line with a certain direction. Okay, and if you actually look at the textbook, I'm just going to turn to the textbook. Okay, if you look at the textbook at page 78, okay, it says over here, okay, that a vector quantity has both magnitude and direction. Okay, the word magnitude, okay, the word magnitude means the number. Okay, and then the direction. So for example, this ship, okay, this ship, let's say the ship starts at point A and it goes to point B. And let's say this distance is about, let's say okay, the distance is 5 kilometers. Okay, so if this is a vector quantity, then I will say this ship is moving 5 kilometers towards the northeast. Oh dear, this is so terrible. Okay, northeast, Timor Laut. Timor Laut, Timor Laut. Yeah, northeast lah. Okay, so the direction where the ship is moving plays a very important role. Okay, when we talk about vectors. Okay, but now we are not really talking about the science part of it. We're talking more about the mathematical part of it. Okay, so the mathematical part of it, I just want you to remember two things. You need to know what is the distance, and you need to look at what is the direction. The direction given to you is always shown by the arrow. Okay, if you see the arrow over here, the arrow will always tell you the direction. So, tengok anak panah betul-betul. You have to look at the arrow very carefully. Okay, so that you don't make a mistake. Okay. Now, there are two ways to write vectors. Okay, ada dua cara untuk menulis vector in maths lah. Okay, the first way is by using from point to point. So let's say this thing is traveling from A to B because the arrow shows us A to B lah. Okay, so this will be A, B, and then over here will be one anak panah ke arah kanan. Okay, to show that this is going from point A to point B. Okay. Another way of writing this is by writing the vector itself in just one letter, small letter, okay, just to show you that, okay, this is vector y, okay, this is vector y. So if I'm going to equate this both, I'm going to say that A to B, okay, is equals to, oh dear, okay, it's equals to vector x, okay, and notice that there's a small caching down here, okay, and that's how we write the vector. Okay, sorry for my horrendous this one. Okay, and that's how we write this one. So it's x and then one caching down here. Both mean the same thing. Okay, it's just that the one with the big letters tells you what point to what point. Okay, the one with the x, okay, just tells you the entire thing itself. Okay, it tells you the entire distance that has been covered. Okay, so in the same way, this vector y, okay, is, okay, vector y is a line that joins from which point to which point, from P to Q. Okay, because look at the arrow. The arrow is going from P to Q. So we write it down as P, Q, and then anak panah ke arah kanan. Always ke arah kanan. Okay, nobody writes vector and then write to the left one. Okay, that one is, oh, sorry. Alamak. Sorry. Okay, nobody writes vector and then writes ke arah kiri, which is like, okay, this is definitely like not accepted at this point in time. Okay, so let's look at question number 2. Vector G to H. Okay, point G to point H is also represented by vector B kecil. Okay, so small b with the caching at the bottom. Okay, and then vector A is from point E to point F. So we write it down as point E to F. This is very suffering, trying to write this. I can't wait for my new pen to arrive. Okay, so E to F lah. Okay, and that's how we represent vectors. Okay, itulah dua cara. Okay, two ways that we represent vectors. Either from point to point. Okay, and or the other way is the entire distance represented by a letter. Okay, the entire distance and direction. Okay, the direction also plays a very important role. Okay, I cannot say that this is vector A, and if I draw another line, let's say I draw a line from here to here, and then I say this is I. Oh no. Okay, this is I, and this is J. I cannot say that this is also vector A. What am I doing? I also cannot say this is vector A. Ini salah. Okay, this is wrong because this is already vector A. Okay, and look, these two are not the same vectors at all. Dia punya jarak pun tidak sama, dia punya direction also not the same. Okay, so this cannot be the same vector. Okay, so depending on the question, every vector is unique lah. Okay, especially the small letter. The small letter one is representative of a certain direction and a certain distance. Okay, so be very careful with this. Okay, if you have this module, then you can answer this number 3 on your own lah. Okay, if you're not very sure, the answers are, well, of course, what is life without answers? Okay, answers are given at the bottom over here. Okay, now the second thing that you need to know is the equal vectors. Okay, equal vectors are, okay, now two vectors are equal. Okay, adalah sama, vector yang sama. Okay, two vectors are equal if they are same direction, okay, and same distance. Hold on. Yes, okay, same direction and same distance. Okay, so let me just double check. Yeah, okay, same direction and same distance. So in this case, case number 1, okay, we find that the the parallel is different. Not necessarily, yeah, they're also parallel, but for now, we are going to talk about equal first. Okay, just hold on about the parallel. Equal must be same direction, same distance. Okay, parallel is slightly different. Okay, so in this case, number 2, we find that there are only two vectors that are the same, which is vector A and vector Q. Oh dear. Okay, vector Q. Because look, vector A is 1, 2, 3, 4, 5, 6, 7 boxes. Vector Q is 1, 2, 3, 4, 5, 6, also 7 boxes. So they must be same direction and same distance. Okay, then they are equal vectors. So A and S now cannot be the same vector because S is so much longer. Okay, they are not the equal vectors because S is so much longer than A. Okay, A and R cannot be the same because although they are the same distance, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, but the direction is opposite. So they're not equal vectors. Okay, so equal vector is same direction and same distance. Okay, likewise with number 2. Okay, let's see which one is the same direction. Okay, it is obviously F and A. Are they the same distance? About lah. Okay, you can use your pembaris and ukur. You can also do it on this one if you want. Okay, they're the same distance. So same distance and same direction means they are equal vectors. Okay, it doesn't matter whether, so if something is longer, like say for example E, okay, E and F, they're the same direction. Okay, they're about the same direction, but they are not the same distance, so not equal. Okay, so this very basic concept needs to be understood at the beginning because when we go into the question, all these things will need to be remembered. What is equal vector? And then later I'm going to talk about what's parallel vector. Okay, in a while. Okay, so the first thing that you need to know, equal vectors are vectors with the same distance and the same direction. Both must be the same. Then they're considered equal. Okay, like two identical twins. Well, identical twins also got some difference, but okay, usually they're equal. Okay, same everything. Okay, not one thing is different. Okay, so take a look at number 3 on your own. Okay, there are a couple of pairs. Okay, there's not just two, but there are a few equal vectors over there. Okay, then you can double check your answer. Okay, the third concept. So let me recap. First concept is how to write vector. 2 ways. Okay, point to point using big letters or the entire distance covered by a small letter with a caching at the bottom. Okay, somebody is messaging me asking me how to write the caching. Let me write it as big as I can and you can see. Maybe it's vector A. It's actually very easy, just write like that. Okay, it's like half an infinity. Can you see? Okay, like that. Okay, that's how you write the caching. Okay, it's called vector notation, not a worm, but that's how you write the caching. Okay, and I also just want to mention that we never write like this. This is wrong. Okay, because we never write like this because this is wrong. If you're going to write the arrow above, it has to be big letter to big letter, point to point. Okay, when we use the small letter, we use the caching. Okay, and neither do we write point to point. Okay, and then caching at the bottom. Okay, we also don't write it like this. Okay, so all these are wrong notations, like don't write them. Okay, please. Okay, Please don't forget. All right. Thank you for the question. Okay, so the second thing is equal vector, okay, which we've just covered. Now the third thing is negative vector. Okay, yes, even vectors can have negative, okay, but it just means that, especially if you're physics students, you will know this. Negative vectors are vectors in the opposite direction. Okay, just like, negative velocity doesn't mean that your odometer sudah pergi ke bawah. It's just going in the opposite direction. So the negative vectors, okay, so if there are two vectors that are negative to one another, they must be the same distance, but different direction, okay, in the same way. Okay, so for example, I can point out to you, let's see, vector xy. Okay, vector xy, look at the direction of xy, is like this. Okay, it's covering about 4 boxes going in this direction, and the only other vector that we can see that is opposite to this is this one. Okay, so vector xy is the same as negative vector x. Okay, I'm going to let this sink in a little bit. Negative vector x. Okay, because vector x is going this way. Sorry, vector x is going this way ke sini. Okay, but we want vector xy to be going this way, downwards like this. So we have to put the negative to show that, okay, if vector x, if we put it the other way, then it becomes the same as vector xy. Okay, it's the equal. And this is what we call a negative vector. Likewise, okay, look at vector st. Okay, from s to t. Look at the direction over here. Okay, and we find that this line is the same as this line. Okay, but since the direction is different, okay, but I want from point S to point T, okay, if this is S, okay, and this is T, okay, therefore I say that vector ST is negative vector A, because vector A is going upwards, I want downwards. Okay, soalan yang mau dari S ke T. Okay, what if I write now vector TS? If I write vector TS like this, okay, if I write vector TS, then I find that it is actually equal to vector A, because it is the equal vector. Same direction, same distance. Okay, so this is a very important thing that you need to note now right from the very beginning. If I change the points over, okay, let's say originally TS is vector A. If I change the points, the starting point and the ending point I change, then the vector becomes a negative vector. Okay, so very, very important point that you should realize from the very beginning. Okay, if I originally set it, let's say from A to B is vector X. So I change the points now from vector B to vector A, that becomes negative X. Okay, so that one it becomes very important. Okay, vector CD. Okay, look at this vector over here. Vector CD, the line and the distance is the same as this one. Okay, small letter C. But since the direction is different, this will become negative vector C. Like that. Okay, and VW, okay, sort of 4 squares, okay, downwards, okay, but this vector B is 4 squares upwards. Okay, so since I want from V to W, I will get negative V. Okay, with the touching over lah. Okay, so that's how we determine the negative vectors. We need to change it over. So likewise, with question 2, the negative vector of P. Okay, let's look at this. P has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. 10 squares to the right. So we're looking for a vector P, but 10 squares to the left. Okay, the same distance covered, but on the other side, okay, to the same direction. So S cannot. S cannot because it is the same direction, so it's not a negative vector. R can because it is a different direction, but the distance is not the same. Okay, so it cannot be the negative vector of P. Okay, if you look at Q, 1, 2, 3, 4, 5, 6, 7, 8. Okay, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squares to the left. So the negative vector of P, negative P, is also known as vector Q. Okay. Like that. Oh, I'm getting better at writing this charting with this mouse of mine. I need to go and get a mouse. Okay, so the first three concepts, the first three concepts for me in this vector world, okay, is actually the most important. The first one is how to write the vector notation. Okay, two ways. Second one is what is the meaning of equal vectors? Okay, equal vectors is same direction and same distance. Okay, the third one is negative vector. Negative vector is same distance, okay, but different direction. Then the two are negative vector. Okay, I mean one is negative vector to the other one. Okay, so these first three things actually lay the foundation for us. Okay, when we talk about vectors. Okay, a lot of people like to jump straight now into the vector because it sounds like, oh, it's like just algebra, a plus a equals to 2a. I know, actually it's that simple. But we need to understand this very fundamental of vectors first. Because when we go into the question now, then your understanding of this fundamental, okay, will become very important. Okay, dia akan menjadi sangat penting lah. You need to know apa maksudnya bila saya cakap negative vector. What do I mean when I say equal vector? And in a while, I'm going to answer Nigel's question, which is bagaimana pula dengan parallel vector. Parallel vector is slightly different. Okay, first understand the meaning of equal and negative vector. Okay, that will become very important to us. Okay, so yes, if you have this module printed out, go ahead and finish this. Okay, I know that I have done quite a number. Okay, and then anyway, the answers are here. So if you're not sure about the answers or if you think the answers are wrong, feel free to let me know. Okay, just give me a while. Let me go and get my mouse. Okay, I just want to double check with anyone. Do you have any questions so far that you want to ask? Or am I going too fast? I don't think I'm going too fast, but well, wow. Okay, so if there's no questions to ask, I'm going to continue. Actually, saya punya hajat adalah untuk menghabiskan sampai muka surat 7. No. Yeah, sampai muka surat 7. Okay, but I don't know whether it's going to be possible. Okay, because actually, vector is not that easy. But we'll try and see. Okay, right. Next one is multiplication of vectors by scalars. Okay, what this means is if I multiply a vector by a certain number. Okay, and this is very normal. Okay, so for example, okay, A, okay, in this case, so state the following vectors in terms of A. A is a vector which is going to the right, okay, and has 1, 2, 3, 4, 5 squares. Okay, so in terms of A means the direction is the same. Okay, in terms of A means the direction is the same. And oh dear, no. Okay, sorry. Okay, never mind. Okay, in terms of A means the direction is the same. Okay, so look, A and then vector A to B and vector C, D, all the directions the same. So kita boleh ungkapkan vector A, B in terms of A. Okay, A has 1, 2, 3, 4, 5 squares. And B has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, since A to B is 10 squares, I can say that vector AB, okay, I can say the vector AB is also the same as 2 times of vector A, 2 kali vector A. Because vector A has 5 squares, vector AB has 10 squares. So 2 times of vector A will be vector AB. Okay, likewise, CD, this is 10, and then 1, 2, 3, 4, 5. So there's 15 squares altogether. 5 to become 15 is times 3. Okay, so CD, from C to D will be 3 vector, 3 times of vector A, 3 kali vector A. So vector A, then second vector A, and then the third vector A. Okay, so 3 vector A's equals to point C to point B. Okay, and that's how we multiply a vector by a certain number. Okay, because any vector, okay, can be multiplied, how many times you want to make it longer. Okay, to make it longer, it can be cut short now by dividing it or multiplying it by a fraction now. Okay, so let's do in terms of b. Okay, this question is wrong. I think it's in terms of b. Yeah. Okay, so this is the original vector. Vector b has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. Okay, so if I have 10 squares over here, I'm going to do EF first lah. Okay, EF is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Naman bantai sikit lah, tapi it should be 20 lah. Okay, so this is one vector B, and then this is the other vector B. Okay, that means there is two vector B. Okay, two vector B's for EF. Okay, but what about G to H? Take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10. There's one vector B so far. And then 1, 2, 3, 4, 5. So there's only 1.5 of vector B. Okay, 1.5 of vector B. Okay, now usually if we write 1.5, we don't write 1/2, or we definitely don't write 1.5. Okay, jarang lah kita tulis. Usually we will write it as a fraction. So we will write it as 3/2. Okay, B. 3/2 means 1.5. Okay, 1.5 times of B. Okay, so that's how we use a fraction, okay, to also represent the multiplication of vector. Okay. Now I'm going to do I'm going to do these two, okay, 5 and 6. Wow, the answers are given here. Never mind, it's okay. So E is written this way. Okay, number 5, I'm going to do number 5. E is this way, okay, and I want to represent vector A, B. Okay, so I'm going to, oh dear, how am I going to do this? Yeah, never mind. So if I have this one box over here, so this is 1. Am I right? Yeah. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4. Okay, so the box is 8 times 4. So 1, 8 times 4. So this is one vector E. Oh dear. Okay, let's do the other one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4. This is another vector E. Okay, so this A to B is actually 2 vector E. Okay. Then, okay, if you do this now, okay, let's say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So up to here is one vector E. Okay. What about here? This is 1, 2, 3, 1, 2. Okay. Oh, sorry. Oh, my mistake. Up to here only. Okay, so this 1, 2, 3, 4, 1, 2. Since the original one is 8 and 4, okay, and over here is 4 and 2, so this is half of E. Okay, so in the same way lah, macam soalan tadi kan sini, okay, so this is 1.5 of E. So this is 3/2 E. Okay, this is a little bit hard to see lah, especially if your screen is so tiny. But if you have your paper, you can actually count the number of boxes. Okay. Now let's take a look at number 6. Okay, the original one is F, this way. Okay, I want to do PQ first. Okay, take a look at PQ. This is F. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the traveling is 10 by 10. Okay, 10 to the right, 10 down. Okay, what about here? This is from P to Q is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's also 10 by 10. Okay, but it's 10 by 10. But look at the directions. The directions are different. So same distance covered, okay, 10 boxes, but different directions means that PQ is actually negative vector F, which makes our answer over here something wrong. Okay, this is the wrong answer. Okay, What about SR? Okay, SR is 1, 2, 3, 4, 5, and then 5 or above for 5. So 5 to the left, 5 above. The direction is different, okay, but it is half of the distance of F. That's why the answer you will find here is negative half of F. This is a combination of everything that we've learned so far. Negative because the direction is different, although the distance covered is the same. But actually the distance covered is half of the original one. Okay, so half of F. Okay, because F is 10 by 10 ma. SR is, sorry, R to S is actually 5 by 5. So they are halfway of F sahaja. Okay, but it's negative because the direction is different. Okay, so we find that in this question 6, everything that we've learned so far, okay, comes together in this part. Okay, comes together in this part. So let me repeat, negative vector, equal vector, and the third one is multiplication of vectors by scalar. Okay, the numbers may not necessarily be nombor bulat. It can also be fractions. Okay, fractions to show you 3 over 2, sometimes it can be 5 over 8. Okay, by and by lah. Okay, by and by we will get there. Okay, the next one, okay, the next one is okay, the next one is parallel vectors. Okay, now what's the difference between parallel vector and equal vector? Okay, it's a question that was asked to me just now by Nigel. It's a good question to ask. It's always a good question to ask. The difference between equal vector and parallel vector is that, okay, equal vector is must be same direction and same distance. Then it's called equal. Okay, so sama. But parallel vectors are vectors that are of the same direction, but not necessarily the same distance. Okay, so they can be same direction, but they're not necessarily the same distance. Okay, parallel can be like this. Okay, let's say my two hands I receive. Okay, this hand is parallel to this hand. Okay, but this hand is much longer than this. Okay, so but we can say that these two are parallel, but they're not equal. Okay, so I would say that parallel is a subset of equal vectors. Not all parallel vectors are equal vectors, but all equal vectors are parallel vectors. Saya ulang, not all parallel vectors are equal vectors, okay? But all equal vectors are parallel vectors. Okay, so let's take a look at this. AB, AB is this way. Let's find dia punya kawan yang parallel. Okay, parallel, if we take a look at this, okay, actually is G to H. So AB and GH are parallel vectors. Okay, but let's take a look at this. How are we going to, macam mana kita mau tulis lah. Okay, AB is 2 by 2 boxes. GH is 4 by 4. Okay, so we find that, okay, if you want to write this properly, I will write this like this lah. Okay, AB, okay, okay, is 2. And GH, sorry for my handwriting. Okay, GH is 4. Okay, and I'm going to put a divide over here. Okay, and I'm going to rub this off. Oh no, alamak. Okay, so 2 over 4. Okay, 2 over 4. So if I'm going to write this, then what's going to happen? I'm going to have 4AB equals to 2GH. And if I bring the 4 up here, I bring the GH here, which means that finally, I will get AB, okay, is equals to 2 divided by 4 is half of GH. Okay, because by doing it this way, you will definitely won't get it wrong. Okay, if I write AB, AB jaraknya 2, GH jaraknya 4. I say 4 because 1, 2, 3, 4 lah. Okay, I'm doing the horizontal. I can do vertical also if I want. It's the same. Okay, then after that I cross multiply. Or I just bring the GH up lah supaya saya tinggal AB saja di bawah. Okay, so we find that, oh no. So we find that AB, erasing. Okay, we find that at the end, AB is half of GH. Okay, setengah daripada GH is AB. Okay, let's take a look at another one. C to D. C to D is parallel vector with who? Okay, look at the direction. C to D is parallel direction with MN. Okay, but they're not equal. Okay, they are not equal. They're just parallel. Oh yeah, I forgot to put the arrow above. Okay, so since CD and MN are parallel, okay, let's take a look. So CD is how long? Let's take the this one lah. Okay, 2 to the left. So 2. Manakala MN is just 1. MN is 1. Okay, so if I'm going to get CD only, I bring MN across lah. So this will become 2MN. Arrow. Oh my goodness. I feel like a 5-year-old teaching you all this horrendous handwriting. Okay, and that's how we write the representation of the scalar which needs to be multiplied with the vector. Okay, number three is EF. Okay, this is very obvious lah. 3 squares up, but KL is this one. Okay, 1, 2, 3, 4, 5, 6. So first thing is EF and KL are parallel vectors. Are they equal? No, they're not equal because sudahlah diorang bukan sama arah tau. Okay, the direction is not the same. The distance is not the same. Definitely not equal. But they are parallel in a certain sense. Okay, they are parallel in a certain sense. Are parallel because the line is the same. Okay, same type of line. Okay, but they are parallel, but since the direction is different, okay, obviously there's going to be a negative over here lah. Okay, let's see. EF is 3. KL is 1, 2, 3, 4, 5, 6. Okay, so I'm going to write EF. EF is 3. KL is 6. Okay, I'm going to put the equal sign over here. Since they're parallel, I can write it like this. Okay, so if I bring KL over here, okay, if I bring KL over here, I will get EF is actually half because 3/6 is half of KL. Okay, but because the direction is different, so it will be negative. Because EF is bawah ke atas, KL is atas ke bawah. So the answer will be negative half KL as written over here. Or, okay, I can also write it as half of LK. Then it becomes positive, which is correct. Because LK is down to up, which is the same direction as E to F. Okay, half of LK. Then you will get it. Okay, last one. Okay, IJ are parallel. IJ, okay, this one, there's only one more lah. Okay, IJ and PQ. Oh, sorry, not PQ. This is vector QP. My mistake, sorry. Okay, vector IJ and vector QP. Okay, vector QP, this way are parallel vectors. Okay, now, are they equal? Let's do IJ is 3. So IJ is 3 boxes. PQ is actually only 2. Sorry, QP. Yeah? QP is actually 2. Okay, so if I'm going to bring this up, okay, if I'm going to bring this up, I'll get 3 over 2 QP. Okay, so IJ is 3 over 2 QP, but because the direction is opposite, okay, because IJ is left to right, QP is right to left, so it will be negative QP. Okay, or if I don't want to have the negative sign, no problem. Okay, if I don't want to have the negative sign, I keep the number. It's still 3 over 2 because dari segi jarak, dia masih lagi 3/2. But I change the direction of the point to point. P to Q. Then I hilang sudah the negative. Okay, although originally in the picture is Q to P, but these two are actually correct. Negative 3 over 2 QP is the same as 3 over 2 P to Q. Because when you change the point to point, then the negative sign hilang. Okay, which brings me to a very important thing that we need to remember through the entire course of this chapter. We need to remember this. If you have a vector from point A to point B, okay, if I change over the B to A, okay, if I change over, it becomes negative vector B to A. Because saya ubah dia punya arah sudah. Okay, which is why I said the vector arrow at the top of the big letters can never be to the left. Because, okay, I have never seen people do this. Okay, BA, and then this way. Okay, although technically it is correct, this and this is the same thing. Ini vector A to B. This is vector A to B. It's technically the same thing. But in terms of mathematical notation, nobody writes to the left. Okay? The world is biased against left-handers like me. So they never write it to the left. Okay, they always write it to the right. Okay, so we have to accept that they write it this way. If we change from B to A, we have to put a negative sign because the original vector sudah ditetapkan as vector A to B. Okay, so for now, just remember when we change the position of letters, we also have to change the direction of the vector. Okay, it becomes a negative vector, which is why the study of vectors is very important because it tells us about not just how far this thing is going, but in which direction. Okay, because the higher level maths you go to, the higher the level of maths you deal with, you find that direction actually plays a very important role. Okay, I always tell my physics students, direction is so important that it determines whether your rocket is going towards the sun or towards the moon. Okay, you can't just count the numbers and then just say, okay, just whatever direction. But then the people in the rocket will be like, are we going to the moon or are we going to the sun? This direction becomes a very important thing when you think about higher level calculations. Okay. All right. I tell you what, we still got some time. So let's take a break. I also need to take a break because I need to drink some water. Okay, and then we'll come back in a while. Okay, we'll pause this recording for a while and then we'll come back. Let's meet back in maybe about 5 minutes. Okay. Okay, welcome back. We are going to continue. Okay, we're going to continue. I hope that we can finish by to page 7 because actually itu saya punya hajat asal lah. Okay. All right. So right now that we have established all the basic fundamentals of what vectors are, okay, especially the concept of equal vectors, negative vectors, and parallel vectors. Okay, and of course the multiplication of vectors. Okay, it takes some getting used to. Okay, but if you have your textbooks now, okay, actually, if you have finished this module and you want a little bit more practice, what you can do is you can actually turn to page 83. Okay, 83 in your textbook over here. You can actually answer most of the questions over here. Okay, I've covered everything except for question 12. Okay, but actually just to give you a feel of what to do when you're doing vector questions. But again, as I said, these are only basic concepts. Okay, if you're here to find out how to answer exam questions, I haven't even started covering the exam questions. All these are very basic things that you need to understand before we can go into the exam questions. Okay, so today's class memang nothing to do with exam. Okay, today's class is really building the foundation so that you can be ready to answer the exam questions. Okay, all right. The next thing that we need to talk about is the addition and subtraction of vectors. Okay, now that we have all these vectors with all these numbers in front, okay, we find that we can add them and we can subtract them just like how we would do if this was a normal algebra question. Okay, for example, oh dear, okay, let me erase this. Okay, so for example, in this one, okay, the resultant vector is after you add everything all together, how much do you have? Okay, the most important thing you have to remember, just like algebra, you can only add or subtract the same type of vector. Okay, so if it's different vector, the different direction altogether, you're not interested in that. They cannot be added together. Okay, just like when we do algebra lah. Okay, so for example like this, 2a plus half a. So basically it's 2 plus, if there's no number in front, what is the number? The number is 1. I always repeat this many, many times, but yet people can still forget. So 2 plus 1 plus half, okay, you'll get 7 over 2a. Okay, and don't forget the tiny caching at the bottom lah. Because if you write this, 7 over 2a, okay, with no caching at the bottom, it is not vector, guys. This is algebra. Two totally different worlds altogether. Okay, so I'm going to ask that you remember to write the caching at the bottom. Okay, likewise in this one, half x plus 2x plus 1 over 3x. If you just press calculator, half plus 2 plus 1 over 3, you get 17 over 6. And don't forget the x over here. Okay, likewise, with minus, you still do the same operation. 7 minus 3 minus half. Okay, and since they are the same vectors, you can do that. Okay, so 7 minus 3 minus half, you get 7 over 2a. It's very basic stuff that we've covered since Form 2. Okay, when you were doing algebra stuff, except that now we're dealing it with vectors. So the problem comes with, what if there are two different letters? Okay, two different vectors, sorry. One is vector A and then one is vector B. It's okay. Separate it out and then do the operation as normal. So this will be 2 plus half A. 2 plus half A will give you 5 over 2A. And then 1 over 3B plus, no number in front is 1. So 1 over 3 plus 1B will become 4 over 3B. Can these two be continually added? Cannot. Okay, you cannot continue from here, guys, because just like algebra, okay, the letter A and the letter B cannot mix. If you cannot do anything anymore, that's the final answer. Okay, so it's very, very basic stuff, just like algebra, except that now we're dealing with vectors. Okay, can the vector answer be like this, negative 3s minus st? Cannot. Can. Why not? Okay, why not? Okay, as long as it follows the rules of mathematics as we have known since from the beginning. Okay, so we don't do this. So, no, I think this is very simple. I'm not going to cover this, but as long as you can plus and minus, I think you should be fine. But this is where I want to work on. Okay, this is where I want to work on, because this one is calculation. Everybody will no problem. But now we need to visualize it. Okay, so this next task is what I want you to pay attention very closely. Okay, determine the resultant vector of two or more non-parallel vectors by addition and subtraction operations. So for example, I'm having this first problem. Vector A plus vector B. Okay, and they are non-parallel vectors. Okay, but they are vectors that are joined together, by all these letters. So we have, okay, so you have this ship traveling vector A, and then ship traveling vector B. Okay, so we find that this entire distance, okay, can be shortcutted, okay, because we see, okay, this ship is traveling from point A to point B, and then point B go to point C. So in short, okay, this equals sign, that means in short, the ship actually traveled from point A all the way to point C in this direction. Okay, therefore the answer to this would be A, C, vector AC. Okay, vector A plus vector B is equals to vector A to C. Okay, this rule is very important. It's called the triangle rule. Okay, the triangle rule is, kalau kamu ada dua vector yang you bersambung, okay, then we find that we can actually close the shape, the triangle, or depends on, later we will see other shapes now. But we can actually close the triangle and say that this is the shortcut. Okay, this is the shortcut. So vector A to C is the shortcut. Therefore, that is the resultant vector of vector A plus vector B. Okay, let's take a look at another one now. Okay, vector B plus vector C. Okay, this is vector B and this is vector C. So both are bersambung, both are connected, and they are flowing in one direction. So I can shortcut it. Vector B to C, C to D actually is the same as going from vector B to D. Okay, in this direction. So vector BD, okay, going in this direction. All right, and that's how that's how you write the resultant vector. Okay, another one, vector C plus vector D, C to D. Okay, again you see that dia punya arah adalah bersambung. Okay, continuous lah. Therefore, I can complete the triangle, okay, by doing a shortcut. So C to D, C plus D actually is from point C to point, this is point E or point F? Oh, point E, okay. So vector C, sorry, point C to point E. Okay, vector, like that. Okay, what about this? Vector AB plus vector BD. Okay, now I'm going to draw this to visualize. Vector AB is this one. Then vector BD is this one. Okay, I'm going to draw the arrow. Okay, so this arrow is over here and this arrow is over here. Let me complete the triangle by drawing the shortcut. The shortcut is actually vector A to vector D. Okay, and that's how we determine the resultant vector. Okay, so this we call it the triangle rule. I think the textbook also has, there are actually two rules for this. One is the parallelogram rule and the other one is the triangle rule. Okay, for me, I just like to call it the shortcut rule. Okay, kalau saya guna ini jalan panjang ini kan. Okay, let's say what if I extend this Okay, if I extend this and I ask you what is vector A plus vector B plus vector C plus vector D? A plus B plus C, sorry, okay, fine. Cacing, jangan lupa cacing. Okay, A plus B plus C plus D. Okay, the shortcut is actually A just to E ini lah. Kan? Saya kasih lengkap ini semua. Okay, I find a shortcut. Oh, actually, I just want to know where is my starting point and where is my ending point. I don't want to know all this long way. Okay, so I remember a few, I remember like some of the students, they complain, so you explain so long and so long-winded, we just want to know what's the shortcut only. Okay, yeah lah. So for those of you who like the shortcut, this is the best chapter for you because vector is all about the shortcut. Okay, vector A plus vector B plus vector C plus vector D is the long way around. Okay, the shortcut is just vector A, E. Okay, A to E. I just want to know where is my starting and where is my ending point. Saya tidak berminat pun dengan yang di antara-antara. Okay, that's basically it. Okay, the resultant vector is always the starting point and the ending point. Okay, provided that all the vectors are joined together and they are in one direction. Okay, if I change the direction, then it's a different story. Okay, they must be in one flowing direction. Okay, all right. Second one. You know what? I'm not going to do this because I think you can do. Okay, let's do number 4. Okay, ABCD in the diagram is a parallelogram. So we have AB plus AD. Okay, this is a bit of a problem. AB is this way, but AD is this way. So how am I going to represent this? Okay, now because this is a parallelogram, okay, I can say that vector AB and vector DC are parallel. And vector AD and vector BC are parallel also. Therefore, vector AB and vector AD, I can rewrite this as vector AB, okay, plus, okay, look, vector AD and vector BC are not just parallel, they are also equal. So I can represent vector BD as, vector AD as vector BC. Okay, oh dear. So AB plus BC will give you vector AC. Okay, and that's the use of a parallelogram. You can actually use another vector to represent it since it is equal. Okay, if it is equal, guys, then you can, change it around so that you can still follow the shortcut rule. Because look, the original question is AB and then AD, tapi dia punya arah adalah not flowing. Okay, before this I say the arah must be flowing. Okay, they must follow one to another. Okay, so I can say that this is flowing because BC and AD are equal and parallel. Okay, so therefore, they're one flow, AB to BC, therefore AC. Let me do question C. DA to DC. Okay, I'm going to rub this off. Okay, DA is this way. D to A. Okay, this way. And then DC pula is this way. Again, both the vectors are not flowing. They are diverged. Okay, two different directions. But because DC and AB are the same and are equal and also parallel, so therefore I can replace this and I can say that this is also vector AD. Okay, because they are parallel. So DA plus AB, let me complete the triangle. Okay, this will be vector DB. Okay, vector DB. Okay, just like that. Okay, so there are many ways that we can find this, especially when you understand how equal and parallel vectors work. Okay, then there are many ways that we can manipulate and you can turn it around so that it follows the rule that you know. The rule that I know is the vectors must flow, okay, in order for me to find the resultant vector. Okay, let me do question number 6. Okay, ABCDEF is in the diagram is a regular hexagon. Okay, a regular hexagon, and we find that AF and DC are parallel, ED and AB are parallel, FE and BC are parallel. Okay, this is the important thing. So let's do the first question. AB plus AF. This one. Big problem because AB is this way, AF is this way. They're not in the flowing direction. Okay, but let's take a look. AF bahkan is also parallel to what? Parallel and equal. Okay, to what line? Okay, let's say kalau saya sambung dari AB lah kan. Where do I go so that I go in the same direction and same distance as AF? Okay, the answer will be from B to O. Kan? So I can actually scrap this and I say AB to BO. Okay, AB to BO will be A O. Okay, it's already bad enough that I'm using the mouse with my right hand. My right hand is cramping already. Okay, so AB to BO. So the point is this: you need to know how to manipulate the vectors by understanding how equal and parallel vectors work. When you understand this, then this whole world is possible for you. Okay, just manipulate it around so that you get what you want. Okay, what you want is one flow, not diverge. Diverge directions you cannot find. Okay, let me answer another one. FA plus FE. Okay, FA is this way. Oh dear. Okay, and then FE is this way. Now, take a look. Okay, if I'm going to go from FA, from A lah kan, where should I go so that it is the same direction and same distance okay, as FE? The answer will be A to O. So I can scrap this out and I say that this is A to O. Okay, FAAO, the shortcut will be FO. Okay, F to O, the shortcut. Okay, so take a look at all these questions, okay, people, and this will be good practice for you, lah. Okay, learn how to manipulate the vectors around. Okay, just look for the equal and parallel vectors. Okay, because those will greatly help you, and you can represent them because they're equal. If they're equal and they're parallel, so especially if they're equal, you can just chuck away the old one and put in the new one, so that it fits to what you want. You want it, kamu mau supaya dia satu alir saja, satu alur saja, one direction. Okay, it cannot be like sekejap sini dan sekejap sana, tak boleh. Okay, it needs to be in one direction. Okay, let me do another one. Let's do a slightly more difficult one, number 7. Okay, ABCDE is in the diagram is a pentagon. Pentagon 5 sides. So AB, Okay, A to B, this direction, and then B to C, this direction, and then C to D, this direction. Okay, so 1, 2, 3. What is the shortcut? Are they flowing in one direction? Yes, they are flowing in one direction. So let's complete the triangle by giving them the triangle. Let's complete the figure by giving them the shortcut. So this is A to D. Okay? It can work for any amount of shapes. It can even work for octagon or whatever. Okay, as long as all the vectors are connected and flowing in one direction. This is the important thing. They must be connected and flowing in one direction. Then it works. Okay, AC plus CD plus DE. Okay, I'm going to rub this off. Okay, AC. Let's draw this. Okay, plus CD plus DE. Are they all flowing one direction? Yes. Are they all connected? Yes. So let's complete it by drawing the shortcut from A to E. Okay. Once you get an idea of how this rule works, you can do vector in almost any situation. Well, yeah, for this beginning stage. Okay. Another thing that I want you to notice, okay, if you haven't noticed this until now, is that if you notice that when the middle letters are the same, let's say if I just purely look at the letters, okay, for example, okay, this one, AB plus BO, okay, the middle letters are the same, B and B, okay, so the resultant vector is actually take away the middle letter, it's just from A to O, okay, even if it's a super long one like this, AB plus BC plus CD, we find that the middle letters are the same, A to B, okay, and then after that C to C. So we can actually cut it all out and just take it as A to D. Okay? And that's why the rule of the one flow, one direction is very important. So that you can cut away all the middle letters and then you will get one final vector at the end, which is actually just a shortcut from A to D. Wow! Is this wow because wow boom or wow too much information for one day? Okay. Yeah, I know it's kind of a lot of information because last week we didn't have any class at all, right? So yeah, so I'm trying to make it up by this week. Don't worry lah, okay? Don't worry. Take it slow. Okay. Yeah, so that's how the rule of vectors works. Okay. Shooking. Okay. So take a look at all the rest. Okay, but I'm just going to do a subtraction now because I've always been talking about tolak, right? But I haven't talked about, sorry, I've always been talking about tambah, but I haven't talked about tolak. Okay, so let's take a look at this. So we have AD, okay, this question, I'm going to look at question 10. Okay, I'm going to look at question 10 and I'm going to see, okay, A to D. So let me draw this one, A to D. Okay, minus CD. Now guys, if we've learned anything from negative vectors, minus CD actually can be changed to positive D to C. Oh no, I'm going to write this out nicely. This is so ugly. Okay, plus DC. Because when we change the direction of the point to point, you also change the sign. Okay, so I can scrap this off already. Minus CD is actually equals to plus DC. Think about it, AD plus DC. Okay, so since they're all flowing in one direction, let's go one shortcut. So actually the answer is AC. Okay, and that's how you deal with negative vectors. Change it to become plus, make sure that it's one flow, and then you can get the resultant vector at the end. Let's do another one, CB and EB. Okay, CB and EB, yeah. So CB is this direction. Okay, EB pula, but since this is negative, okay, I'm going to rewrite this as CB plus B to E. So that the reason why I do this is so that I can get a one flow, B to E. CB to BE. So the shortcut will be C to E. Like that. even if let's say I don't have this figure lah, okay, I look at these letters also saya pun tahu sudah ni. Okay, if I look at the letters, oh, the middle letter is letter B. Sorry. Oh no, I can't erase this off. Okay, the middle letter is letter B. Okay, so actually I can just shortcut lah, because the similar point is point B. So it's actually from point C to point E. And that's how you deal with the negative vector. Okay, change it to positive vector and follow that direction of the positive vector. And you change the negative vector to positive vector by changing the point of starting and the point of ending. Okay, because it's the same. All right. Okay, so I want you to try to answer the rest of this. And I think, can I continue with this? Hold on. Okay, I think I will stop here for today. Okay, because 5 pages of this is quite a lot lah. Okay, there's a lot for you to think about, and I want you to make sure that you guys are okay with this section first. Okay, because yeah, I don't think I can go into the next section yet. Okay, so let me just recap what we've done today. First of all, we've learned about the concept of vector. Okay, the concept of vector. Secondly, what is the meaning of equal vectors? Thirdly, what is a negative vector? Fourthly, what is a parallel vector? Okay, hold on, I done. Okay, so the answers for this one is all here. Okay, then after that, we learn about the multiplication of vectors by scalar. Okay, like what do these numbers in front of the vectors mean lah? Okay, then of course the addition and subtraction of vectors. Okay, and all the addition or subtraction of vectors, of all the tasks today lah, okay, the one that I really want you to focus on is the one on page 4 and page 5. Okay, when you if you know how to do page 4 and page 5, okay, then at least you know that foundation is there. Okay, the first step towards learning vectors is building that foundation. Okay, so I want you to take some time to take a look at this task 2 and task 2 in this page 4 and page 5. Yeah, okay. So to answer Aidan's question, I didn't have the answers for task 2 and task 2, all 13 questions in task 2. It's okay. I will give the answers. Jeremy says that you have to trust your own answer. Maybe we should all trust Jeremy lah. Okay, so yeah, maybe if you want, you can ask Jeremy for the answer lah. Okay, now guys, if you want some more exercises, okay, and I really recommend that in the next 2 days, if you have a lot of time, okay, go and do some more questions. I would suggest that you actually focus on page 92 and 93. Okay, 92 and 93 in your textbook. Okay, there are a lot of examples over there just to get yourself used to this negative vector and then changing it to become the resultant vector. Okay, actually the next part that I want to talk about is very short. But we will talk about it on Wednesday lah. Okay, and then we'll see what happens from there. Okay, so are there any questions? I'm going to stop the recording now. Okay, thanks everyone.